Hello all, welcome to the Basics Academy. This is Solana Blockchain Fundamentals and Architecture, a 5 units 3 credit course in the BSc Blockchain Technology program. Let's get into it. Solana Blockchain. Lecture 1, Blockchain Ecosystems and the Evolution of Solana, in which we are going to talk about how Solana came into existence starting from the 2017 white paper, then the design goal of supporting 50,000 plus transactions per second, and at last we are going to have a look at proof of history plus Tower Byzantine. In today's lecture, we are going to cover overview of blockchain ecosystems, wherein we will talk about L1s, the blockchain trilemma, and where actually Solana fits. Then we will talk about the genesis of Solana, how Solana came into existence. Moving ahead, we will look at the journey of Solana blockchain from testnet to mainnet. And at last, we will look at where Solana stands today. What is a blockchain system? As we all know, a blockchain is a distributed, append-only ledger which is replicated across many independent nodes. A blockchain ecosystem is everything that is built around that ledger. Let us have a look at what are the different ecosystem layers a blockchain consists. First is the consensus layer, which is responsible for how the network agrees on certain conditions, or how the network comes to a conclusion is decided by the consensus layer. After that, we have the execution layer. On this layer, the smart contracts or the programs are actually executed at the execution layer. Going ahead, we have the data layer. This data layer is the ledger itself, which is immutable and which is replicated across all the nodes that are running the blockchain network. After that, we have the application layer, and the application layer, we know there comes dApps or decentralized applications, then wallets and exchanges. And at last, we have the tooling layer, which consists of SDKs, RPCs, and explorers. So the ecosystem layers consist of consensus, execution, data, application, and tooling layer. The blockchain trilemma. What exactly is the blockchain trilemma? It comprises of decentralization, security, and scalability. However, the main problem is at any given point of time, only two of these three properties can go hand in hand. Let me explain that. As of now, the number of nodes running the Ethereum blockchain is more than 9,000. So Ethereum's decentralization index is higher. Also, the security index is higher, but the scalability of Ethereum blockchain is not at the enterprise level. Hence, Ethereum takes into consideration decentralization and security, thereby compromising scalability. Now, let us take another example. In case of Polygon blockchain, so the number of nodes that are running Polygon blockchain or the number of validators is approximately equal to 101. In that case, the scalability is higher on the Polygon blockchain, but the decentralization aspect is not as compared to Ethereum blockchain. So Polygon blockchain is kind of taking a trade-off at the decentralization layer and going with scalability plus security. In simple terms, out of decentralization, scalability, and security, at any given point of time, either security or decentralization will go hand in hand, or decentralization or scalability will go hand in hand, but never three of these will go hand in hand. This is the blockchain trilemma. You may have heard about layer 1 blockchain, layer 2 blockchain. Let us try to understand amongst layer 1, layer 2, where actually Solana sits. First, as soon as we heard the term blockchain, the first and foremost thing that comes to our mind is Bitcoin. So Bitcoin is an application of blockchain technology. It is a layer 1 blockchain which uses proof of work consensus algorithm. Secondly, we have Ethereum plus layer 2 rollups. Ethereum again is a layer 1 blockchain which is programmable because we can write smart contracts and create dApps on top of Ethereum blockchain. Secondly, Ethereum is modular. When we say modular, as we have looked into the previous slides, the blockchain ecosystem layers comprises of consensus, execution, data layer, application layer, and at last tooling layer. In case of Ethereum, each of these layers are executed differently. Ethereum as of now uses proof of stake consensus algorithm. Plus, in order to scale Ethereum, there are multiple layer 2 blockchains such as Arbitrum, Base, Polygon, etc. At last, we have Solana. Solana is again a layer 1 blockchain. However, it follows a monolithic architecture. That is, the consensus, execution, data, each of these things is executed by a single node, or the execution happens at the same level. Solana uses proof of stake plus proof of history consensus algorithm. When we say monolithic, all execution, consensus and data reside on a single layer. In case of Solana, why performance was the founding problem? No major blockchain came close. The bottleneck wasn't bandwidth. It was the time that was spent by the nodes talking to each other just to agree on the order of events. This single insight treated time itself as the bottleneck. And that is what led directly to proof of history, which we are going to cover in lecture 2. In case of L1, the TPS is roughly around 10 transactions per second. In case of Tendermint, which runs 100 to 200 nodes, it was approximately 1000. However, Solana promises 50,000 plus TPS with 200 plus physically distinct nodes. What was the founding question in case of Solana? It was, can a decentralized network of nodes match the performance of a single computer? The answer to this question led to the birth of Solana blockchain. Genesis of the Solana blockchain. One engineer's sleepless night became Solana's founding insight. Anatoly Yakovenko published a white paper in November 2017. The title of the white paper was Solana, a new architecture for a high-performance blockchain. The central idea of the white paper was to directly encode the passage of time into the ledger itself using a verifiable sequential hash chain. This idea later on became proof of history. That is, a cryptographic clock that lets validator agree on transaction order without constantly messaging each other. However, proof of history is not a consensus mechanism by itself. It's a solution to the clock problem that consensus, later on we are going to look into it, Tower BFT then builds on top of. From Loom to Solana Labs, building the team and the funding behind the white paper. November 2017, the white paper got published. Early 2018, the founding team was assembled. In 2018, it was renamed and incorporated to Solana to avoid confusion with the separate Loom network. In July 2019, the Series A closes with a $20 million round led by Multicoin Capital Funds, full-time development of the network. From testnet to mainnet. In 2019, the first public testnet was released. Then the team ran benchmarking clusters across 2,200 plus physically distinct nodes that were located across 23 data centers on AWS, GCE, and Azure. Then the team demonstrated the network could actually sustain 50,000 TPS in the testnet benchmarks. After that, Tour de Sol. This invited external validators to stress test the network and earn tokens for participating. Tour de Sol was important because this public adversarial testing phase was a deliberate step before trusting the network with real economic value. And on March 16, 2020, the Mainnet Beta goes live. 2017, white paper published, the proof of history concept was introduced. 2018, Solana Labs founded, the team assembled in San Francisco. 2019, public testnet plus Tour de Sol and a $20 million Series A closes. And in March 2020, the Mainnet Beta launches live production network. This marks the end of lecture 1. In lecture 2, we are going to have a look at Solana architecture, proof of history, and Tower BFT. In case of any questions, bring them to the next session or post on the course forum. Solana's founding philosophy: a decentralized network of nodes should be able to match the performance of a single node. What they actually did, rather than compromising decentralization for speed, Solana's team chose to re-engineer every layer of the stack, be it networking, consensus, timing, transaction processing, memory, or storage. Where Solana stands today. As of now, there are 50 million plus monthly active addresses on Solana blockchain. And in a month, it processes more than 3.5 billion transactions. The cumulative transactions since mainnet launch has crossed 400 billion plus. And there are approximately 770 active validators. Talking about the breadth of the ecosystem, on Solana, there are DEXs, lending, liquid staking, dApps running. People are issuing NFTs and digital collectibles. There are consumer and mobile apps supporting gaming. It also has DeepIn, which is decentralized physical infrastructure, and a payments functionality for low fees suit micropayments. Solana is a network which is still maturing. Even though the network has experienced multiple outages, a reminder that beta in the name is not just branding. And validator hardware requirements, which we are going to see in lecture 3, are demanding because we are running everything on a single layer, which has put downward pressure on the total number of active validators over time. Let us preview what are the 8 innovations that Solana has brought into the blockchain space. First is proof of history. Second, Tower BFT. Then what is Turbine, Gulf Stream, Sea Level, Pipelining, Cloud Break, and Archivers. Each of these concepts we are going to look into depth in lecture 2. So what are the key takeaways from today's introduction to Solana lecture? A blockchain system is more than its ledger. It spans consensus, execution, data, applications, and tooling. Talking about the blockchain trilemma, decentralization, security, and scalability, Solana's bet was to re-architect the stack rather than trade away decentralization or security. Solana began as a 2017 white paper, and it was built around one idea, encode time into the ledger itself, later which was named as proof of history. Solana today is a mature, high throughput network with real growing pains. Both facts matter for how we evaluate it as engineers and auditors. That wraps up this session. If it helped, like and subscribe so you don't miss the next one. Questions? Drop them in the comments below. See you in the next lecture.